Hello, everyone. Welcome to the Melbourne Blender Society. This is our first attempt to broadcast at Google on Air, and already we're running 5 minutes late. So I'm Andrew Buttery. That's Alex Fraser. Yeah, thanks. We're just getting set up at the moment, so give us another 5 minutes or so, and then we will be ready to go. Anyway, so yes, we'll leave it running in the meantime, but yeah, it's going to be another 5 minutes before we start. Okay? Have fun. Back in a moment. If you're wondering what I'm doing, this is a Surface, so I'm actually getting information to send to my account so other people can join in. So apologies if I'm kind of poking you in the eye or something like that. Okay, back soon. You've joined the network here, Alex. With our computer? Yeah. Remember that everything is you on my behavior, no swearing.
Calling from the audience.
Yeah. Okay. That's the wrong invite. The right invite. Why haven't you sent? Why are you seeing my outbox? Why aren't you going? Sending at 96, 96, 97, 98. Don't you love Outlook? Send receive error. Yeah. I'm trying to send out the URL of the video broadcast so people can log in because we'll tweet it to #B3D. So, because the event that I set up that was public just connects me to a regular video call, not the Hangouts on Air video call. So yes, if you're watching this, Google, there's some real usability issues you've got there. Yeah. NSA, talk to you guys at Google. How can I get this from this machine to the real world? I'm actually just logging into Twitter here. And good, it's got me. So okay, I've tweeted the Hangout to P3D, so I have no idea if anyone's going to get this or not. We will know next time. Oh, don't close that tab. Don't close the broadcast tab. Okay, right. Let's get this.
Are we ready to go?
We're ready to go. Excellent. You need that job. Okay, so I'm like, welcome to meeting March 2015. So hopefully tonight we'll have an interactive meeting. Our guest speaker, unfortunately, contacted us earlier today and is not available. So Alex, well, Fred, will be doing a quick thing on particle remeshing. So
I must admit also that I'm partly responsible for the schedule.
you know, you just self-flagellate yourself in front of the world. We are broadcasting now.
We don't want to
Yeah, those are the much entertainment we can take. So instead, what we're going to do is a section on particle remeshing. So going to be the campaign coins making of. So I'll show you what that looks like. Not blocking anyone's view. No. Okay. So this is what the moved it. That doesn't always happen. Somebody moves it right when you expect it. So let's do that. That's the rest of the video. So a friend of mine makes these coins that you can see here for role-playing games, board games, other bits and pieces like that. So when you're you're playing Dungeons and Dragons and you're at the inn and you want a flag and a veil, you can actually give a real coin. Now, last year he's actually started doing Kickstarter campaigns around it. So he decided he wanted a nice flashy animated logo to be given. So that's the one we did here. So I'll just show it again. There's no sound, you can get an idea of what we're doing there. So you'll play again, so it's lovely sort of fuzziness to begin with, then it comes obvious, and then a big flash across it. So, this is cool. It works exactly similar. So this is basically the sort of three things that I'd like to walk you through tonight, depending on what you're interested in. The first is the rigid body physics around the coin. The second one is how I did the bump map on the actual coin, because it looks 3D, but it's actually a rendering trick for those. I'm sort of like, I know you're a beginner, you're reasonably beginner. If I said bump map, would you know what I was talking about? Excellent, cool. Like that's intermediate. So, and the third one is how I did the flash and all the other. Because this is This is done in, the coin is done in 3D, all the other elements are 2D, and they were brought together in the video editor. So we'll get through those and see how we go. So starting with, now warning up front, I haven't prepped for this, so it could be a little rusty in places. Because this is actually going to launch it next week, and I finished this work a couple of weeks ago. 24 version. Now, something I like constructing my projects in multiple scenes. I don't try and stick everything into one scene. There's a couple of reasons for that. The main reason why is I actually like to take my components and render them out separately, and it's much easier if I do them in a scene individually. And then, so I create what's like an edit scene at the end. So you can see this. What we might do a little experiment and see if I can join the Hangout here as well. And then you reckon next time? Okay. You probably can't see what the text is on. But, okay, executive decision. What we've got here, so when you've got an edit, so I have all my video editing, so it's sitting in one scene, so I don't mess up where I'm actually doing my animation and other rendering and modeling and other bits and pieces. So it's a useful thing to do, because one of the things that people often get caught by is under the post-processing tag here. If you've got the sequencer enabled, this option here, enabled, and you have anything in the sequencer, when you hit Control 12, like F12, or render a sequence, it won't render what your camera is seeing, it'll render out what's in the video sequence editor. So if you put it into a separate scene, it means you will never have that problem. And I've been caught by that a couple of times. Anyway, let's go back to the actual coin scene. So this is the actual scene set up here. That way. And you can see the animation running there. So it's actually a pretty simple setup. I just used the rigid body physics with gravity. I haven't changed the gravity, it's just completely standard. And the way I've done it, so there's something that you might have a little bit difficult with. Obviously the coin's dropping, but there is another object here. At the moment, I'm set to wireframe, and that doesn't interfere with my drawing. So that's actually my ground plane. So this is a collision object, the coin is a collision object. The reason why I put wireframe is so when I'm in camera view, I don't get that. So if I change it back to raw wire, I can see actually what's going on. So a handy little tip to get stuff out of the way. Now, the next thing is that you also notice that thick, it wasn't a single plane. Because when you're using rigid body physics, it needs to do calculations on the collision between the two objects. It doesn't calculate very well with a flat plane, because it's a long time ago in the 90s. I used to test video games. One of the games we used to test the video, it was a racing game called Death Cars. And what we found is that if you got the car going really fast, because there was one pickup that was like a jet, the calculated the in a wall, say on this frame I'm here, on the next frame I'm here, that it was moving so quickly it didn't actually calculate the collision, it didn't intersect. So what would happen is when you hit the rocket, then you'd go flying through the walls and off into no man's land inside the actual game. And it's the same sort of thing here. If you want good interactions, you've got to have bodies for the actual meshes to interact with. So there's a little hint there. Now, the actual, one of those beautiful things about Blender is you can actually move stuff around and play with it whilst actually playing with it. I'll pull that out of here. that. So, a bit further. See hidden away there. So I've set the collision for the cube. And I also have the collision set here for the coin and for the coin. And you'll notice that I've actually changed the default values. I'm not sure what the default values are. Let's do that quickly. There is a reset default value option. So there's another handy little thing to do. And now if I play it, hopefully it will recalculate sim. Not very exciting at all. And what's more, it's not sitting in the right spot, it's not doing the right. So the first step is to actually start playing with these responses. So if I change the friction, you can see now we've got no friction, and it actually starts doing some, actually it's just dropping flat now, so that's good, because you don't want it sliding off. And the other object, cube, we change that. Okay, that's, yeah, almost there. So it's still giving us, we can't just plug one value in and get the desired result. So what I did, I'll just undo all these, is I've actually, there we are, I've actually keyframed this. So this is the beauty of Blender. You can keyframe nearly anything. You think you can't, but nearly anything. So that it actually, if I open up the dope sheet here, you can see that I've actually set keyframes for the friction of the actual, so that I can for the bounce, and it changes after the bounce, so that when it comes to land, so it'll actually, first one will be a big bounce, and then just doesn't move back. So, and it stops and settles really quickly. So that's one of the things you can do. You can actually keyframe lots of stuff in the physics space. You can like make things, you can enable them to be part of them, to disable them. You can set, you think it's certain amount of force before they're enabled or disabled or movement. So there's lots of fun things that you can do with them. So, but there's so that's a practical example of using the rigid body physics in a project. You can see the result again. So that's how that's done. Just very quickly, the camera setup is very easy. We have our coin, we let gravity fall, so just get the camera underneath. Easy. To get the fuzzy effect, because we're using a camera is what's called depth of field. So this is so you can see the camera is sitting there, so sitting underneath. And if you go to the camera tab, you can actually change, you can set here the limits actually display what's on the screen. And then you can set the depth of field here. So the depth of field rating basically is how fuzzy it's going. Sorry, that's the distance. So and then the radius is size here affects how fuzzy it is. So I went through, I think that's maximum fuzziness. So on a higher value cube, more defocus. Let's see, do I keyframe or what stay the whole range? No,
Just rubbing the hard way.
yeah. Put it here. No, you're right. So yeah, you can see I've started it. When I come to the end, I've set it really low, so it's in perfect focus. So that way, when it settles, everything's in focus. the actual using limits, you might just see it sort of around here. By doing this, when I change the distance, you'll see that move. So you can use that to set your actual, the point where it closes. So again, if you want that fuzzy, again, you can animate it. So if you want to do like Matt, you'll know what's the term? Focus. So if you've got like two people talking, you've got one person talking, every focus in the first front and the person close to the camera is fuzzy, and then they start talking and you want to pull back and get them more in focus and try in the background out of focus. That's the way you do it using a keyframe like that. Change your distance. Or you could change your aperture and voice focus. Excellent. So there's some real different pieces on that. So, any questions so far? Mark?
Does the coin have any mass? Well, that's not necessary to get to
You can
behavior.
You don't need to have it. It does actually have, there is a mass rating in the physics part of it. I think I've left it at the default, which is 1. There it is, no, 10. I'm not sure what will happen if I change it. Let's see that. It doesn't seem to have much effect. So for the interaction, probably because the other object is not moving. I'm going to go out on a limb here and say if they were running into each other, then the mass will have a definite effect. So if this is set to 10 and this is set to 1, then this is like a bus hitting a small vehicle. So this one will keep going and the little one will get knocked out of the way. But because it's just going like that, there's not much interaction. So I suspect that's what will happen. So, Alex?
Does the point start with the flat or is it on the end?
No, it is actually completely flat. So it's completely flat. Yeah, well, I played with the settings until I got it to flip the way I wanted it to. So,
It's impressive.
yeah, well, I'm lucky because the thing about rigid body simulation is I can play with these values and immediately see the difference. Hopefully, I might just stop it and restart it. I have auto keyframe on. I normally have auto keyframe on. But you're right. I will make it clear. Even one again. Now we do it. No, it's not going to put the other objects together. That's right, because it adds them together, doesn't it? Yeah. So, same result. Whoa! Hey! So now, yeah, that one works pretty well. Now we're doing a double pistol. So, excellent. So you can. This is these kind of simulations. You can turn around pretty quickly, unless you're like using a very large number of particles, like on a wall falling over or something like that. I agree. Once you start going out into smoke, fluid sim, other different things like that, it can become annoying. And I did actually the first version I did for these guys, the first logo, which we did talk about the World Country Day, used a fluid sim, and it just drove me back. So I won't be using the fluid sim anytime soon again for a commercial project. So, okay, any other questions around the physics stuff? No. Okay, let's move on to materials. No, I'm not going to read it. Because this does actually have a material. You can see it's not a ridiculous material, it's just a little bit. So it's got sort of basically two components. Really, it's only got 2 or 3 components to it. So you've got your actual color here, which is this sort of line, and then you've got the displacement, which is this line here. So the colour, as you can see, we've got a diffuse, which is like a gold coin colour. The glossy is almost identical. The glossy is just the amount of reflection. I've done HDRI in the world, so it does get a little bit of reflection, but not a lot. High definition resolution. I think it's what it's called. But what it is that it allows you to create. Okay, so a simple. If you want to create a simple lighting field world, create a big sphere and get it to project light into your world. HDRI is a simple and quick way to do that without having to create any geometry. So we might save that. We might save that for another talk at the time. Like into your scene. So it is. If you look at any of the work by Andrew Price or Gleb or any of those guys, it's an absolute statement. And when you see guys wandering around movie sets or those making of with big silver balls, that's the kind of thing that they're actually doing, getting the images of the environment and the lighting and stuff like that, so that they can then match the VFX elements to the actual footage that's being shot on the day. So you must see HDRI, you must do that one time. Because it's really cool. It's amazing how much information you're doing when you're in film. So you can see we've got the diffuse, the glossy, pretty much the same colour, just a matter of reflectivity. And we've got sort of flowed out here. This image, this is the actual image that we use. So here we go. Preview, so you can see a little preview there. What it looks like down in the corner there. So we might start turning things off and see what happens. So if I turn off, for example, if I turn off this image texture, use M to mute enough, and that will turn it off. So you'll see it's turned red. And you'll notice I still have a little bit of stuff there because it's got a bumpiness, and turn that on. Should be perfectly clear. So now you can just see that it's really using I think it's probably using a flat 50-50 glossy to diffuse. So it's fairly boring to. What I've got is a map that I've used to actually mix the two colours. Then we use the same bitmap to actually view the display. So so now you can see there's a little bit of reflectivity where it is. It's where the ridges are, and the flat pieces are the reflective pieces. And then when I throw in the other image texture, it now creates a little bit of height. It's hard to see, but it's actually easy to see on the real. So the way I did that is I was actually given a I did actually make up a few different concepts. So I actually received from them. A scale graph of the actual image. So actually, the company that did it actually got an artist to create a 2D vector graphic of it, so they can use that material. Like flat artwork, if you want to convert it into a 3D object, you can actually export this as an XVG and import it directly into Windows. So that's another thing you might do in next time as well. It is very cool, but there's a couple of little tricks. What a warning in advance, it creates horrible topography when you try and actually measure it. So if anybody knows the trick on how to make good topography out of it, that'd be great. But one of the somewhere here, I should have logo 20. So I've got there's so just reopen it. I tried using a blend. I tried using the blender scroll, and so this is the artwork in SVG. But what you can also do is you can actually export it as a bitmap. So first step is take the artwork, export it as a bitmap. So now people know between a vector and a bitmap. Yep. Cool. So a bitmap is actually a series of pixels, like a picture. So each of the elements are actually curves. So if I underlook that context, eventually I should get to the point where I can drag. There we are. You can see it's actually made up of a series of curves that are mathematically defined, as opposed to an actual sort of like theory of 10 by 10 pixels. The beauty is, if you have a 10 by 10 pixels thing and you zoom in, you get horrible blocking Nintendo graphics. Yeah. With an SVG, you can zoom in and you can continue. There are ways to stop it. You can keep zooming, you can zoom in and zoom in and zoom in and zoom in, and you get no blocks. Yeah, that's the best. So that's the advantage of a vector graphic. So which is fantastic for desktop publishing because with screen you're dealing with 72 dots per inch generally. With sort of like publishing, printing, at least 600, if not 1200 or higher. So you have really nice crisp edges and stuff like that on my. Anyway, you can, once you've actually exported it as a PNG, here we are. So now this is an actual picture now. It's no longer a graphic. So if we zoomed on this, it would get all blocky. But what you can do then is I ran that into Vim and used so what happens is that the way bump where there is a value of so what happens is that when you use it as a bump map, is that the renderer says, oh, where I see white, that's going to be this level. When I see black, it's going to be higher. So then it creates this artificial kind of brand bump map because it'll look great straight on, but if you turn it by 90 degrees, the surface will still be dead flat. So you can actually tell, hey, this is a rendering trick. This is not the actual geometry that makes the object is not truly displaced. Now, in my actual animation, there is only a few points where it's perfectly in focus. All of those are when it's dead flat. So that's why I can get away with it. As soon as it starts turning and you go, it's a bump map, it doesn't look very realistic, it then gets fuzzy. So I can cheat instead of that one. But to actually create the fuzziness, to create the raisedness of it, what is I took the bitmap, then I applied a series of blurs to it, and then stacked them. So a big blur, a little blur, a big blur, and a little blur. You stack them all on top of each other. The curved edges of the actual bitmap. Sorry, the bump map. And then map it onto the object and use it for displacement and for the coloring. So probably haven't explained that very well. But any questions there? I'm going to do an online making of as well, so I'll try and do a better explanation. If you can actually, hopefully, you get it. If you get this to read it nicely, why it's not reading nicely. Why we're getting pink, why we're getting pink. Pink usually means you're missing a texture, by the way. So, but it should. That's interesting. It's interesting because this is a very interesting. This might actually be a bug because it's showing us the preview of the material correctly there. But it's saying I've got missing textures here because that's the import material. No, that's the visual actual preview of the material. So, because the viewport material is here. So, but I've actually chosen to use the rendered output. So this is actually trying to do a quick. That is a cube object. Not better. Yes. So if I turn it off there, woohoo! Yes, thank you.
This is why we have smart PC on the roof.
Good point. However, you'll see my coin is still coming up pink. So there is something missing. Let's just see if what happens when I try and actually do a real render. There's something wrong. So somehow when you're missing something somewhere. You can see the fake raisedness there. If I turn that 90 degrees, you see that actually. That. Yep, another gotcha because we didn't keyframe. I didn't keyframe the transformation. So now it should. Yeah, there we are. And now you can see it's totally flat. So it doesn't have any. And the reason why you use bump maps for a couple of reasons. The main thing is if you want a really subtly raised surface, you're going to have to increase the polygon count. More polygons, slower renders, more memory it uses, and so on. So it is really a way to create. It's sort of it won't get you all the way there, it'll get you part of the way there, and it's a quick way to do things. Yeah. Yep.
Is that make it only suitable for really stationary objects? It's quite moving objects.
No, well, actually, you probably prefer to use it for high-speed moving objects. You're not going to focus on.
So you can put motion blur.
Yeah, you can hide a lot in motion blur. You can hide a lot in depth of field. Yeah. Yeah.
Okay. So you can complement it by having a bit of roughness to it and then really high detail.
So yeah, so you could do something very simple like just put where's the displace modifier on it. Actually, the displace modifier won't work very well because this actually has very little geometry. It has, you can see it's one face. So a displace modifier actually will not work very well on this at all, if at all, because there is no faces to displace. So, yeah, you can see it's actually subdividing the edges, but it's not subdividing this end one face. It's got more than 4 points or 3 points representation. So you need the actual displacement of the surface to work. You need to have quite a lot of geometry, right? So to work here. So what you might do. So we might just take this guy and we'll apply a displacement modifier to it. Extra. So see it's not working very well. We're just subdividing. That might be a little bit specific. Coming down, we can make clouds. There we are. Thank you. So you can see it's actually displaced the geometry. But, beforehand, when we just had only 6 faces, then it would basically go, well, I can't really move it. Won't give you the kind of interaction with the surface you want. However, you'll now notice that I've got something in the vicinity of 2,648 vertices. So I've gone from 8 to, many hundreds of thousands, in fact, it's more. So that's why, if you like games are a good example where bump mapping is used a lot of, because it is cheap. So when you're doing a static kind of regularly, you want to say, look, I'm happy to set the machine up for 24 hours. And that's to some extent, that's a lot of what Retopo is also about as well. Retopology is taking a very high density mesh and reducing the mesh, the actual polygon count, while still retaining the overall shape. So that's a little bit about the displace function as well. So when do you use bump mapping? When do you use displace? Or combine them, as Alex said. You create something like this. And when we do the actual, probably turn this down a little bit. And then so you just give it a little bit of a bump to give it a displace, and then a bump map over the top to give that little bit of extra detail. And again, Andrew Price is a master of that, so he does what tutorials in that space. Okay, so how are we going? We need a break. Editing section. Yep. Okay. Been a long day at work. So here's the actual video edit. So, see, at this stage, the first stage, all I've got, these are my actual rendered frames from the coin. So what you can see then is I've actually created a series of sort of stacked effects here. So if I actually mute that one, mute that one. So you can actually, again, the same way we muted the modifier, you can mute tracks. It uses the hotkey H rather than M, unfortunately, which is a bit inconsistent. Hopefully somebody will fix that. So if I mute that, now you'll see, now you can actually see what's hidden under the coin. So what I've got is these bars here. And originally I actually created these in 3D and I rendered them coming out to the side as part of the actual animation. And then my client went, yeah, why don't we use the real ones? Because that way it'll work better with the actual final animation. So that was it. And we actually used the real bar. The other thing is I've actually set up I'll turn one of them on. I will. So to get the actual image, this is not 3D animated text, it's like a motion graphic. What I've done is I've taken a 2D piece of artwork and I've used image offset here and animated so it looks like it's going out that way. So if I change this, see if I can move it back and forth. Okay. And this actually is the entire bar. So the bar is about that wide. Obviously, I don't want to pick up this side of the coin, or one that's over here sticking up that side of the coin. So only for this one, only stuff on that side is visible, and the other one, only stuff on this side is visible. So I'll just by turning the actual mask on. There. So now you can actually see this is the masking element. So anything on this side is still good. The right one. Turning that one off. And now you can see the two of them together. And now you can see it's all basically so one. There's two of them that way, one that way, that way, the other one has a mask on this side.
Are you scaling that? Or?
No, I'm just, it's the up. Again, I've got the SVG and the upward. 1080 by whatever the settings are. There, 1920 by 1080. So the original, this is the original artwork. Yeah. All I've done is I've loaded it in, and then you can use by using the offset. You can actually physically move it around the
I'm only moving, not stretching.
I'm not stretching it. Right. So, yeah. If I just go, sorry, I'll roll through. I'll just go to the image viewer and I'll show you. It's basically it's the full bar. Both of these instances of the full bar, I'm just hiding half of it. Does that make sense? And then I lay the coin over the top of it to hide that. So I'm stacking them up in layers. Just like a fireplace. Sure. So how to apply the mask? So let me hide that one again. Let me hide, I'll hide one of them, so I'm just working with one of them. So this is, so again you see I can move it around back and forth. If I move it too far, it'll hide behind the left. So the actual mask is down here. So you can see add script modifier mask. And if I turn it again, like most modifiers in Blender, you can turn it off. So that might give you an idea of what's hiding under the mask. The reason why I had to mask it is I put the coin back, stick it out the side. So after, stuck it over here, mask this half, and then animate it, so only that half goes that way. So you can actually, you can use quite a few things as the actual mask, the mask frame as such. So in this case, I created a custom mask. That one, so that's the custom mask here. There seems to be, I had a few little problems with it around what it treated to the alpha and what it didn't in some occasions. Here, this is clear and on the mask, so you would expect this to be pretty clear for the bar, but it doesn't seem to work that way. It seems to actually work off the white and black values. Either that or I don't really understand how it works. But at the end of the day, I got it over the line for the client, so it doesn't matter. Does that make sense? So yeah, so you can use it for, you could use basically all sorts of masks. I'm going to try doing an animation where I have little stars, like spiral stars here, and basically animate the sequence, and then use it to actually wipe between two different images. So I use that as the white mask. That's a sort of an idea I've got for what I want to try in future. So that's how I do the bars. Is the swoosh. So you can see it's very quick. It only takes a couple of frames. So you can see it coming across. Now this one is actually a pre-rendered animation. So again, I did a 2D animation in a separate scene. So then I output a frame sequence, and you can see this is the actual material here. And the output, if I remember correctly, so you can see what it renders is actually just this white bar, created as a straight texture across a white field. So it's a flat object. Again, the position, to get the position to move, just keyframe the position keyframe the position of the texture on that one. So you could keyframe the position of the actual then we run it into the compositor. You can see I'm using for the compositor, I'm using the backdrop option, backdrop option. So I can actually see the results. So if I start playing with values, you can actually see it pretty much straight away what the effect is. So yeah, basically, so what I've just very simply, a lot of this is just tweaking colours and making things look interesting and adding a bit of glow around the edge of it and so on. But the core pieces of it really are, so this is the graphic coming in. So this is the graphic, which again is loaded off a static frame. You then brought in my rendered output here. So this is what I use as the white to mix between the two to get the effect. So this kind of leaves this. And then this actually, we combine it, we set the alpha, we combine the alpha, the output. I don't actually, I can't remember what a lot of these things do. So, but yeah, it's all basically you get the effect of the swoosh going across it, and where the swoosh has been, it's now solid, and where the swoosh isn't, it's still clear. So we have, as it goes across, it creates sort of like it comes up with a highlight, so then blur a bit, give that some glow, and then it comes back down. So then the glow comes back down as the swoosh crosses past it. And then it's basically rendered out as a frame sequence. 20 frames. That's it. So I then take the frame sequence and run it into the edit. That's another bit of a feature, is that it will remember, I think the default setting is, it will remember the scene that you last used for this layout. So when you change the layout, it'll change the scene for you. There's an option settings. Sometimes it goes well, sometimes so now it's just running, as you can see, as a frame sequence here. And one of the features around it, if you load in the two frames, instead of the two frames here, but like so handy to have. And to do that, you can do it by just grabbing the handles on the edge, on the end. So I can hold it for as long as I want. And like that, and then it fades to black. And what the final one looks like is that. Yeah. Right. Any other questions?
So I just produce that particular effect. Can you actually pack it into a library and then use it? You can.
So there's a feature called node trees. So what you can actually do is there we are. Exactly remember where I was. Is that you can actually set up a collection of, say if I choose everything except maybe select those two, invert the selection. Okay, so you might like to add one, I'll take that one shortly. Won't let me group render layers. I don't have any render layers selected. It's silly. I don't think I've got any render layers. Oh, okay. Yeah. So yes, once again, user error, not the program. So what you can do is you can actually group all the nodes, and you'll find that a really complex node setup, this is a lot, where it makes it really much easier. So we can actually give this, a name. So let's call it light swoosh. Take that one. And I'll just save this in new versions intact, just in case, because it was like 2 days before I was finished. I was in about 7 days before the deadline, and I was just sitting back and relaxing. And I was thinking, yeah. 2 days beforehand, I had to find go, can you now make it spin up in the air and like it's in a dungeon setting? And it's just like, next version. So any of you project managers will know all about the next version. So once we've created it, it's called Light Swoosh. I've saved this. So if I get another version of Blender up, what I should be able to do is go to the compositor. I remember how to do this correctly. And you can actually link it or append it like any other. So go there, no tree, Light Swoosh. Now, it won't appear immediately. I go add, group, Light Swoosh. Now, obviously, you need to fix these, alter all these values. And there is a feature. If I went back into the group, you actually give these all a name so they make sense. Right. Which is something that was added 2 versions ago. When I did actually there's a tutorial on my website on how to do this. Right. And it's careful about this because I did update that tutorial.
What was the command that you used to group those, and how do you ungroup them?
Okay, so there's one of the conventions of Blender, generally to put things together or to assign stuff, control letter. So add a parent, control P. To ungroup them or to unconnect them, Alt. So Alt G. So at the moment, open a group, tab, opens it, tab, closes it. Alt G, undoes it. Control G, puts it back together within the group mode. So yeah, it's something, there's, you can actually get stuff like this. There's people who have node tree libraries because it's anything to do with the node editor. It's not just compositing trees. You use it for material trees, for both Blender internal and for cycles. And hopefully you'll be able to use it for the node-based particle system that Lucas is working on. So we'll be able to create a library of stuff you can just go, yep, I've got a node tree, does that, does that. Because I don't know how many times Andrew Price has done a vignette on one of his tutorials, and I told him and I said, why don't you just do it as a node tree? You know, it drives me nuts, it drives anybody who's seen any of his tutorial nuts. And his answer was, which is, it's interesting because I'm involved in a lot of tutorials, if they don't know what the unit's level of skill is doing, they have to do all the basic steps pretty much every time. So, but anyway, but yes, I haven't been yet node tree to do exactly that. And it's good because actually there's a color one, I've got like a fuzzy diffuse kind of one, and I've got a desaturation one. So if I want to combine all three, I can just go 1, 2, 3, link them all in, link them all up, play with the day.
Create the node tree,
Yeah.
package them up, and then if you need to use it for subsequent things, you can just draw on the package.
Yeah. Well, I don't know if you've noticed, I actually have a directory here called node tree. So all of my node trees are stored in here. And this is very easy for me to save and load stuff from key location.
How do you, so you got the node tree that time from the thing itself?
Yes.
Is there a way to, extract the node tree and keep it on a folder somewhere, or have
So this is my node tree. That I actually I have not added much to it. I've done this compositing node trees, for example.
so they're all got blend files?
There. So here for the node tree. So these are as I mentioned. There's my 3 vignettes. Where goes film grain, dirty leaves, transform bloom, a bit of bloom, can't go past that. So I won't add so you see I've actually got them laid out here. So then I'll file, I'll choose one, close, that's interesting. Thank you. I didn't know that. So we'll go somewhere recently here, no tree, let's do 10. Make it here, there it is, and now I can edit it. So now, save the blend file, and now whenever I go to my node tree, I now have a push node tree that I can add in anywhere. So yeah, as I'm slowly building up a library of various stuff. Key haze is one I really want to add. I can work out a good one. Other bits and pieces, just all sorts of stuff. Key haze with a map, so you can actually, so if you had like a jet flying by, you could use say the output of the smoke sim as the input into the heat haze and stuff like that. So this is the beautiful one. So you put it. There is. Cool. I'll have a look at it. Any other questions? Okay.
Segue weapons that you use, so the old version of these ones, like those for
Oh, okay. The old one.
So you abandoned that one, so we can get the work on the work.
I didn't. What happened was that when they gave me the I'll show you the full old ones, and I'll show you what I did around some concepts. Oh, yeah. The concept, there's a joke in the concept, that's right. And they're only 10 seconds long. So this is a advertisement for why you should be very careful with what you name your directories and how you store stuff. Output version 20, that's what we do. Both pretty close. Too hard to see if it's so dark. No, this is a failed one. I end up having to put Boolean, doing all sorts of cheating. The actual thing itself is true fluid, so I had to fix that. It's going all over everything. It's flickering here because this gets really thin. The problem with the fluid sim is you play with the viscosity at all, or you change some of the settings and you get completely different. The thing is, so the objects are not moving. If there's motion, it's actually the camera. There's a couple of really awesome ones a couple of years ago, which looked fantastic, but they were standing still with the fluid just pouring into a static object and the camera moving around. What we've got here is an inflow sitting inside the crucible, and this needs to be moving along like this. So the first thing that happened was that all the fluid just ran up the back of the crucible and started flying out the top, which is very realistic for molten metal. So, as you saw, that was version 20, and it just drove me nuts. I sat there hours and hours. And fluid sims are really annoying in that when you try and do to get acceptable up, quickly, you crank the resolution up, and now it behaves completely differently, and it takes you half an hour to find out that it behaves completely differently. So fluid sims are a real pain. So much so, I'll just quickly show the concept of some sims. Can't really see this one. I quite like this next one, but unfortunately I did. So that's where and actually dropping again, which I agree with. But yeah, the whole fluid sim, no. I would not. I would do something with the fluid sim with escape. I would never try to do something with animation. Anyway, good segue into Alex.
All right, so yeah, as Andrew mentioned earlier, we were going to have another speaker, but due to my own stuff up in schedule is not available. It's not too rough. But I'm going to show you an alternative to the type of fluid sim that Andrew used. So you used the old style fluid sim, which is a grid-based solver. I think it's technically named for a lattice fault grid. So I'm going to show you a different one using Python. So similar to the concept. Here is the text that want to fill with some sort of mission, and you're going to pretend that it's like a multi-method. And then we've got these mold. And actually, these ones are just sort of containers for the particle. It's just a collision object. And the particles are actually emitted by these little trains here. And if you look at the fluid settings, the particle settings, you can see that we've got fluid energy, and we're using the classical SPH solver, which is something on the bottom. It's a little bit more accurate than the double density solver. But really, for this kind of thing, it doesn't have to use the old. And then the play animation. You see the particles come out and they fill up. And again, you need to tweak this sort of thing, so I've got particles that are floating around the top. I only made this back a couple of hours ago. So with a bit of tweaking, you could have to make some force fields, which would pull particles into the levels, which is a nice thing about using particles instead of the other solver. Then you can add all sorts of force fields and catches particles around them, sort of fudge the simulation of the
So saying demos on the road in particles for fluid simulation, is that an extension of this, or is it the whole same?
So these are fluid particles. if they weren't, then they wouldn't stack up like that. We have a sort of feeling that body behaving in the fluid, they will just on the bottom, just in way. And these particles are actually interacting with each other and pushing each other away so that fill that space.
Can you change the size of the particle?
Yeah.
So that means you get more realistic fluid effect?
You can make them smaller.
Yes.
Yes. So the smaller they are, the more realistic you can make them.
Right.
And the longer your simulation time is.
Okay. Right.
So there's two aspects to that. There's you can see there's the sort of dominant outline around these particles. That's the collision radius. So and then there's another one which is in the fluid setting. Yeah, the fluid interaction radius. And that's something that you can't see here directly, but in this case, it's probably something like that size around the particle. It's moving around the neighbor. So it hooks the neighbors, and then the neighbors sort of push the other particle up. So there are a lot of settings to tweak, and it's actually a little tricky to get right. But if you stick with it, you can get really nice results. And once you learn how to do it, you can get possible results in quite a short amount of time. You can see in here how the particles sort of fill up that end shape, they sort of flow around. Until recently, particles suffered from a major drawback, which was that you render them as a fluid with a hard surface. You can only render them as particles, like either as halos, or you could instance an object there, maybe a sphere, to symbolize particles, or whatever you like. So it didn't look very realistic. You could also instance metaphors and very parameter play scale. But there's a new add-on which was released in demo, as a demo version, maybe a few weeks ago, which is pretty cool. It's by somebody who calls themselves Pyro Eagle on Minecraft. So I think they've contributed quite a few different add-ons. Like I think they have a particle-based simulation tool that was a little bit like the fluid, but more like clumps of sand or snowmen. So they've made an add-on which creates that iso surface around the particle, so that you can see the surface of the fluid. So first of all, I need to make sure this add-on is enabled, or it won't update for anything. So already you can see that there's that mesh created around the particle. And if you look at it in wireframe mode, there is the mesh. But around each particle, there's a sort of surface. You can see what's happening inside that edge. Just a shell around the particle. And you see this if you zoom in on one of the and then you can see it through playback to the time. Timeline. You can see through the timeline and see it fluid evolve with a nice smooth surface. one of the problems is that you get these sort of spheres around the particle, which looks a little unrealistic. And the way to mitigate that is probably, well, again, there are parameters you can play with. These are the settings for the ISO surface that's being generated. You can change what you take around. I've got a very good video of that somewhere.
Would work pretty well if you had like a mercury material or something on it, something that you actually put in your life.
Yeah.
But if it was really small, then it would look like that.
Yep. So if the particles are smaller, then it's in the sphere. If the particles are smaller, you could tweak the settings of the ISO surface and I think make it look more like a smooth surface go down to like rather than like you can keep particles being so large. Of course, the more particles you have, the longer fluids intake, and also the longer considerable particles. Then no, you can do constraint oceans. So if you want to do like a ship going through an ocean, then you might use this for vicinity around the boat, and then just try and like you sort of merge with the distant ocean. And then just a quick demonstration of the different settings that you can have. Here we've got this is 3,000 particles. Each particle has an interaction radius of 0.1 and viscosity of 0.5. But if I play with it a little bit more continuation. This time there are 4,000 particles, so not that many more. The mass is smaller. The interaction radius is smaller. The stiffness is higher. So and I need to re-enable that on default. Right, so here's the ISO surface. So I've also reduced the size multiplier to 3 because this time the particles are sitting a little bit closer together, so we don't need to make it such a large. We give each particle such a large buffer. So I might have smoothed it a bit more as well. And I think this one looks quite a lot better. It's far less blobby. It looks more sort of viscous and gooey. And the video of this. So you can, again, you can step through timelines to see how it evolves. And the video. And again, it needs tweaking. Maybe I should stop the finishing 10 frames earlier, stop from sitting on top of it.
It's still, it seems to be such a much better result in the fluids than we were using before.
I think it's much easier to have control over it. Because like I said, you can have force resistance, you can tweak what it sends for this type of surface duration, you can tweak what it sends for the fluid itself. And you can move like really easily. So I'll start a new one to demonstrate this. I think I did a demo like this one previously. I'm just going to set up a little loop to demonstrate that you can move the object, you can move the imager, you can move the collision object visually. So we'll make the particles move on the grid, and we'll make them all and how far apart should we go? Roughly I don't know, 0.13 or something. 0.13 blending units, which means when we turn on fluid settings, you get a classical. You get this little spacing hint down here. What you want to do is get that spacing to match the spacing between particles we're going to get. So if you're emitting more fluid volume, that spacing there can match that spacing. But first, I'm just going to make this into a fluid. And the damping factor up to 1, so the particles don't bounce off the surface. You just want them to sort of hit and then slide along. Okay, so the way we adjust the spacing, and also, sorry, so the classical one is to have a couple of subframes, so turn on maybe 2 subframes and adaptive subframes. So what that does is it uses more CPU cycles for each frame to try and get a better solution for the measurement. If that's too low, then it's still not exploding. So if the fluid is exploding, then that's the first place to look and start to explode. So you want to make this about 0.12. So you can do that by reducing the mass or increasing the resistance. It goes beyond 2, so we can make it 100. And then the interaction radius is also in rem units. You want it to be 2.5 or 3 times spacing. So we'll make it 0.2. And then let's see what happens.
Do it safe?
It shouldn't crash, but it exploded a bit. Just make 1,000 that is like massive, because it's only going to simulate the frame we're going to see anyway. So it explodes and they just sit there. See how they're popping a little bit? That's because the subframe is too low. So increase that and you make it 700. But there's more going on. That's looking a little bit better. There we go, that's a bit nicer. So maybe we press 12.1 and then a little bit. There we go. So now we've got a nice fluid. So it took a bit of messing around. The more you play with it, you'll understand how the now that we've got that, we can have some fun with it. rotate. Stuff is much easier to type with the rotate it around there. You can scale it, you swatch it up, catch them all again. Yeah, and so this sort of functionality has been implemented for quite a while, but it hasn't been that useful because there hasn't been a way to generate that surface. So that's it. I think you could use
That's just for the add-on.
the ISO surface, yes, to the add-on. So I'll show you where to get that. So if you just search for Blender Cube surface, so so if you go to the Blender Arts folder, Cube Surface add-on. So we've got some demos there. And go to this link here. And it uses a compiled library to generate the artist. So there's a different version for Windows, Mac, and Linux, unlike a lot of add-ons that you just type in text. And he's got a donation box, and I'm going to donate because I think this is really cool. I think you can get these entire things on this. So if you like, donate.
Can you show the white one that you have on the Blender Art page?
I will.
It's really awesome.
Yeah, yeah. Just quickly though, when you download this, if you're downloading for Windows, you also need to follow the instructions here and get the Visual Studio redistributed. If you just search for that and go install that first, then you install the add-ons.
Yeah, it's going cool.
So this is without the ISO surface.
The book moving because it's going to be adaptive.
I think that's the ISO surface that's being done by. Yeah, this is adaptive. Oh yeah, so I'll just quickly show you how to set the ISO surface up on this model because it's not immediately obvious how to do it. But the way it's done, first of all, is add on a name. So, and if you're using it a lot, they've been settings now, so that's always enabled. Then what you do is you add and and it's got nothing in it. When it just sits there at the origin, you don't need to move it. Just leave it where it is. All you want to do is go to the object settings, scroll down to the bottom, and you'll find this cube surface. Add an ISO surface. You choose the object that you want to use as your data source. And at this point, you're going to call it. And then the voxel size is important. So this is also in Blender units. This is going to be the size of this is the resolution of your mesh. Make this number smaller to get a higher resolution. The smaller it is, the longer it will take. So be conservative when you change it, you must be there for a while. But we'll make it, so remember the particle spacing was like 0.12 or something? So that would be a good place to start, 0.12. The spacing, I don't think we adjusted the particle size, so we're just going to play around with something. It doesn't update until you change frames, so just go left or right. There it is.